Good morning, everybody, and a very warm welcome to this, which is day 2 of the webinar series for the Target 190 Plus programme. Welcome to those of you that are joining us for the first time this week today, and welcome back to those of you that were here with us yesterday. My name is Carl Butler-Garnham. I'm the programme manager for Target 190 Plus, and on behalf of everyone, I'd like to thank you for lending us your eyes and your ears this week to let us talk to you about the exciting work that we're doing as part of the programme. Once again, as I mentioned yesterday, we're staggered at the level of interest that we've had in the programme, and it's really spurred us on to try and give you some really good information as part of this event. And again, it's not just limited to the UK. We've had people interested in questions and registrations from around the world, so it's really encouraging for us as a programme team to be able to present to you like this. As I said yesterday, the first webinar that we had at the beginning of October was to build awareness of the programme, and this series of webinar over the 3 days is really there to help us delve into specific areas of the programme, show you some of the work that we've been doing, and give you an indication of where we're going next with this. But before we delve into a recap of where we've got to and a touch on yesterday, let me just remind everybody that this is a live Microsoft Teams event, so you will be able to see delightful faces like myself, the presenters, but you as delegates will be on mute and will not be visible to anyone. This event, as I said yesterday, is being recorded, so both video and audio, and we'll be making all of these recordings available after the event for anyone to re-watch or send on to anyone who might be interested. And in terms of the agenda, again, the agenda, like yesterday, we're here for 1 hour and 30 minutes, which includes the question and answer session at the end of all of the presentations. And we have the facility submit a question during the live event on the MS Teams platform. But we will take all questions that are submitted and commit to answering them after the event, and those will be published along with the video recordings of the webinar series. Finally, before I hand over to Nicola for the recap, please remember to stay hydrated. Please make sure you're sitting comfortably for the next hour and a half, and hopefully, like yesterday, we hope to entertain you and enjoy the event today. For those of you that were here yesterday, I can tell you that we do have more musical instruments in the background, so if we run into some technical difficulties, we will probably break into some. So, Nicola, let me hand over to you to do the recap.
Thanks, Carl. And I'm really looking forward to day 2 of our webinar too, to build on all the presentations that were given yesterday. But before we go into the detail, I'd just like to take a moment to remind you of the drivers behind the programme and the scope it covers before introducing the subjects to be covered today. And I know some of you that were here with us yesterday heard some of this yesterday, so today I am going to be much briefer, but it is important to understand why we're doing this work and the drivers behind it. So where are we on the network today? Our conventional signalling systems are ageing, they're resource intensive to design, commission and maintain, and it's becoming more and more expensive to renew and upgrade them. And they don't offer automatic train protection, still relying on TPWS. When we carry out renewals and maintenance, the design of our systems mean we need disruptive access to commission and maintain them. This isn't very good, as it does cause impacts to our customers. And we need a lot of manual resources to do the work, as well as having issues to manage when human errors occur when working on the systems. When you put this into the context of our existing signalling renewals work bank, it just shows we've got an ever-growing backlog, and we're in a situation where we just haven't the money, resource or access to deliver what is required using current systems and techniques. So not a good place to be. And if we move to the next slide, recognising these problems with conventional signalling and the potential from ETCS, this brought us to this R&D programme, Target 190 Plus, and a future CCS strategy sitting behind it, all based around moving towards modern digital technologies. Its driver is all about enabling us to address that need for sustainable signalling system on the network, something that has become even more important after the impact of the COVID pandemic. And our focus is really on reducing the current average unit cost rate of signalling to a sustainable level from 490k to 190k or lower, a figure that we believe is sustainable from our work on the long-term deployment plan. And we're also looking to address other identified industry challenges by changing how we do delivery and reducing access needs. So to do this within the project, if we move to the next slide, we have 29 projects which take as their starting point radio-based ETCS, and by that I mean ETCS level 2, level 3 and radio-based limited supervision. Yesterday, our webinar focused on some of our policy or system enabling projects, which look at how to move from conventional signalling systems to ETCS across the network by the use of cost-effective sustainable system platforms. And we had presentations on our enterprise architecture and reference CCS architecture projects, our option selection rules project, and on the essential backbone for future CCS systems, communications. And if you're able to join us tomorrow, for the final session in this series of webinars, we'll be focusing on our projects which are focused on supporting decision making and working with the supply chain. But for today, we're moving on to the delivery enabling projects in the programme. Data is a big focus for us in this area, and so we'll start today with Matt providing us an insight into two projects in this area, Asset Information Efficient Collection and CCS in the BIM environment. Here we're looking to move from the current situation where every project and supplier has bespoke data needs which feed into project delivery, needs which then need to be sustained through the life cycle of the asset, or situation where we collect data once, we maintain it and everyone uses the same data. We'll then move on to our validation and simulation environment for future CCS projects. Here, John and Clive will share the results of a feasibility study we've carried out in this area and explain how we can reduce signalling system commissioning times using a synthetic environment to enable scheme development and allow the seamless transfer into supplier detailed design processes through to full validation and verification of the system. Then James will round up today by focusing on business continuity. He'll share the work we're doing to update the current business continuity policy based on conventional signalling to support future CCS systems to provide a safer railway designed to protect network performance. So I think we've got some really interesting and exciting presentations on the agenda today, and I truly believe all these work streams will in the near future be able to start delivering real benefits to the way we deliver CCS projects on the railway. And I'm hoping by the end of today that that's something you will also agree with. So I'll hand back to Carl to take you through the agenda for today.
Thank you, Nicola. So just a reminder, here is today's agenda for today's webinar. So up first, we have Matthew Weingarth, who's going to take us through the Asset Information Efficient Collection and CCS and BIM environment projects. Before then, we have John Walker and Clive Roberts from University of Birmingham as part of UPRIN, which is the UK Rail Research Innovation Network. I think I've got that right, Clive, but I'm sure you'll correct me. For the simulation environment, future CCS and generic validation project. And then I'll be handing over to James Yolland from Ebony, who will take us through the business continuity project. We'll then wrap up the day with a second Q&A session before we then articulate next steps and close the session today around about 11:30. So on that basis, let me introduce Matthew Weingarth to take us through his projects.
Good morning, everyone. My name's Matt Weingarth and I'm a Principal Innovations Engineer for Network Rail. Hopefully today I'm going to show you some interesting visuals. The last time I did this presentation, it took 3 hours. So I've got 15 minutes today. So hopefully we'll get through it. OK, so the two projects I'm going to talk about today are Asset Information Efficient Collection and CCS in the BIM environment. We've combined these two projects into what we refer to as survey and design. Asset Information Efficient Collection is about how we collect data, for example, from forward-facing train-borne systems, or harvest it from known data stores already in use. CCS in the BIM environment is how we take that data and use it for downstream processes, such as design, auctioneering, or training. The key thing to remember with BIM is it's not just about having a shiny model, It's about how we live and operate and maintain with that model going forwards. For these two projects, we wanted to establish some quick wins and develop some proof of concepts. We were able to do this based on the work we have done in control period 5 with conventional signalling and conventional tooling. Also, two key digital railway projects. The first one, efficient scheme design, looking at efficiencies in future signalling scheme design process, but also the early contractor involvement automated design report, which gave us some really good steers on how to manage data, the governance, the warranty of that through the life cycle of projects. The end game is to develop an integrated toolset with modularity in mind. So today I'm going to show you some proof of concepts, very focused around technology and data. We haven't forgotten about people and process. These are obviously key pillars in future developments. So today I want to show you, we want to move from the art of the possible into the art of the doable. So our vision and the issues we're trying to overcome is the time spent on low level activities, the amount of manual intervention that is required, and the amount of manual intervention to correct errors that are introduced. And hopefully we can spot these early in the process, because the later we leave it, the more rework has to be done to correct errors later on. We want to increase the effectiveness of data exchange through downstream processes, whether that's across the industry or different disciplines. And we want to make sure interpretation of rules is done consistently and in the right way. Next slide, thank you. So the opportunities and the benefits these two projects are trying to address: we're trying to increase optimization through automation. We're trying to integrate with existing known data stores and data information and other areas. We want to increase the efficiencies of these processes, and to do that we've got to be more accurate in how we do stuff and what we do and how we collect data initially to maintain that single source of the truth throughout the life cycle of a project. One of the key themes that isn't on this slide is safety. Even though we're trying to do things quicker and cheaper and drive down that SEU rate, as Nicola was just describing, safety has to be paramount, and we have to continually drive up safety standards. Ultimately, we're trying to collect data and feed downstream processes from BIM to digital twins, including things like the synthetic environment. And you're going to see a good presentation later on from Clive and John discussing synthetic environment. Next slide, please. Thank you. This is a high-level overview. And for those of you who are familiar with Network Rail's grip stage, which I think's move into what we refer to as speed, this is a high-level life cycle of a project. So today I'm going to show you proof of concept around the first few stages, the asset discovery, and then moving that data into the scheme design and detailed design. Ultimately though, we have to have these data management processes and maintain that trust and single source of the truth throughout the life cycle of the project, including in the handback into operation and maintenance. Thank you. Next slide. So moving on now, I'm now going to show you a few proof of concepts around the asset discovery stage. Where we want to get to is less of what we see in the top left, old methods, boots on ballast, and more to what we see in the bottom right, which is automation, doing things quicker, safer and cheaper. The box you see on the front of a train has evolved from our control period 5 work. This is a fully engineering accepted, risk assessed and competency based process getting on and off the trains. We have buy-in from all of the train operators and freight operators. Ultimately, this is an example of how we want to collect data quicker, safer and cheaper. Next slide, please. So the challenges of what we're trying to overcome, we're trying to increase the positional accuracy of low cost, rapid deployable systems. Yes, we can get high level of accuracy with detailed survey systems. However, there is a time and cost implication with these. We're also trying to adhere to a lot of different standards, whether that's the new L1 geospatial standard or the track standard, for example. We're trying to overcome the amount of surveying tools that are out there and proprietary formats that are used. So in doing that, data exchange isn't as effective as it needs to be and should be. The opportunities are obviously the inverse of the challenges. We're trying to increase the accuracy of these rapid deployable systems. We're trying to generate and maintain that single source of the truth. And to do that, we're using common data formats. And for our proof of concept and our conventional tooling, we use the semi-structured data file type called SDEF, which I won't talk too much about today, but it is a constant theme throughout these proof of concepts. Thank you. So without talking too technically again, what we tried to do with this proof of concept was trial lots of different equipment in the box we've developed. So along with BAE and a SME called One Big Circle, we tried different IMUs and different GNSS equipment, different GPS units, different cameras, different phones, and we tried to apply map matching algorithms and different techniques to increase the accuracy, because we want to be able to get better, quicker data, safer, to feed those downstream processes. One Big Circle brought their AVA platform along as well, which gave us a really good way to distribute the data and video, as opposed to putting hard disks in the post, which isn't very effective or efficient. So ultimately, we tried lots of different techniques, lots of different equipments in this box to achieve high levels of accuracy from this system, ultimately to feed these downstream processes. Thank you. So there is a slide before this normally, but it doesn't appear to have loaded, the one which shows the system overview. If not, do not worry. So in essence, there is normally a slide before this, which is the system overview. It basically shows how the box is put on the front of a train. The data is uploaded via 4G and 5G to the cloud, where it is all geographically and geospatially positioned. It's also aligned with the corporate map, giving it an ELR, track ID and mileage. That is basically fed to an online repository where people can access the data safely and securely, and then they can do those engineering tasks such as undertaking measurements or tagging assets. Basically, we're trying to generate data which will feed downstream processes, and in this case, machine learning. Just before I talk too much about the machine learning though, I will give you a few key facts about the Tail Lamp Camera Plus box we have developed with BAE and One Big Circle. We've got over 20 projects and programs using it, from the East Coast Digital Programme, who we're starting to align and look at their processes. We're working with the RBLS, so Radio Based Limited Supervision project. We've got the Trans-Pennine Route upgrade covered. One of our key projects is also the Intelligent Infrastructure Programme, where we're using the same box and techniques for their use cases, such as detection of hotspots on third rail, which I'll talk more about later. We've got over 6 routes using it, from Wessex to the northern routes to Scotland. There's 11 different suppliers already using this equipment. Plus, ultimately, we've captured to date well over 5,000 miles of the network. So when we've captured the data, what are we going to do with it? We're going to use it and apply it to those downstream processes we've already talked about. And the first one is machine learning. So what we're trying to achieve, we're trying to geolocate the information and data. We're trying to extract features. So for example, we're not just trying to identify a signal, we want to identify the number plate on the signal so we can align it back to a known data store, and we're trying to feed back and train the system so it's always learning and improving. Okay, next slide, thank you. Here we go. So this video shows an output from the Reyes system. So this was taking the video and we worked with Fujitsu, and it's the same system as used on Western and Wales. Their use case is slightly different because they're using it on laser point cloud generated from a high grade system. We're obviously trying to do it from low cost, rapidly deployable video to find those efficiencies. Hopefully you will see that as the video progresses, the amount of false positives are reduced. This is a combination of training and learning the system, but also data science techniques applied, whether it's camera calibration or approach angles, or even simple things like being able to spot it in multiple frames on a run up. Ultimately though, we are trying to generate the feature extraction to align it to data stores to feed those downstream processes, whether it's starting to build up things like the digital twin or feeding the synthetic environment. Okay, next slide, thank you. This shows the graphical user interface that has been developed with a bit of laser point cloud loaded in between Paddington and Maidenhead. This was obviously one of the routes that we trialled with Western and Wales. Thank you. Next, I'm going to show you the same data fed into another machine learning platform. This one is called Atlas, and this was developed with BAE and an SME called Enable My Team. You'll see the box on the front of a train, and in this case, it's been set up for the II program, Intelligent Infrastructure, looking at thermal hotspots. So the system plays through. You'll see the video here. It automatically detects the speed sign on the left and can extract the features, and it's a 10/60. What you'll see now, we can train the system ourselves. So for example, if we want to start tagging point toes, we just drag the box around and the system starts learning. Ultimately and eventually it will start detecting those assets itself automatically, taking the human being out of the process. It's really easy and quick to navigate. Just click and drag on the screen. You'll notice that the blue lines show where we have the video, the green where we actually with the trainers at the moment, the icons where we've already detected assets, and the blue boxes where we have photogrammetry or point cloud. It's all geographically located and map matched to ELR tracker D and mileage. The features are extracted, but we're trying to generate that data to feed the downstream processes. And here's an example of our SDEF file, which could be used to feed the synthetic environment. We can generate point cloud from video. So this is the photogrammetry that Nicola referred to in the first webinar. So we're trying to add that benefit and unlock those capabilities for enhanced engineering tasks, whether that's doing clearance and fouling points or measuring cable lengths, for example. If we're lucky enough to already have a laser point cloud, that can be loaded in to be interrogated. And finally, we're going to see how this was used for the AI program to detect those thermal hotspots in third row. So T190 adding benefits to other programs and projects, which is great. Just let that finish. So I've shown you a few proof of concepts around the asset discovery stage. We're now going to move on to how we use that data in those downstream processes. It is worth noting again that data management is a key theme throughout the life cycle of what we're trying to achieve here. That was a key steer, as I've already said, from that early contractor involvement automated design report. So please bear in mind the data management processes around governance and warranty and maintaining that single source of the truth. So now we're going to move on and see how we use that data for those engineering tasks and early design. Thank you. So what we're trying to achieve, we're trying to visualize the data. We see BIM as a view of our data. So we're trying to move from traditional 2D schematics and 2D information. Now, this is an example of our sketch tool in the top left. Whether this has generated the data from drawing from scratch or loaded it in from the machine learning, we want to be able to model it and visualize it in real time. But ultimately, it has to have the information that underpins it to give it that richness and to add value to the data. So we want to be able to model and view it in different views depending on what our use case is and who the user is. Thank you. I think we're starting to get the idea, but what we're trying to basically do is take our physical world and make it into a digital replica. And I know digital twins mean a lot of different things to a lot of different people, but ultimately we're trying to take that physical world, replicate it so we can do better timetabling, better design, even do training and better validation and simulation of the real world. So I won't talk too much about this because I said earlier, Clive and John are going to give a really good presentation after this one on the synthetic environment. So next slide, please. So just another note on the sort of BIM visualization stuff we're trying to achieve. This is a highly rendered model of the Warrington project that we undertook. It's only a subset of the information. But what is key here, we took that semi-structured SDEF file generated from the sketch tool or the machine learning, and we've applied BIM standards to it. So it's all aligned to things like COBE and IFC rail, again, giving that added value and added benefit to the data for those downstream processes. We also loaded in things like CSVs and bits of paper to basically start to see how we can build up this digital view and start to undertake those rich engineering tasks with a really good view and interpretation of our data. But finally, I'm going to come on to a few data management principles. So as I've already said, today I've shown you quite a lot about the data collection in the bottom left hand side. I've shown you quite a lot on the visualization in the bottom right hand side. I've mentioned it a few times, but the version control, the data governance and assurance is absolutely key to this process. So as such, we've undertaken a couple of proof of concepts, which I won't have time to talk too much about today or show you. But one of them was with a company called Soprasteria, where we used new technology such as DLT, which stands for Distributed Ledger Technology, to basically see how we can exchange data in a trusted and secure and open way. We've also done some proof of concept around more traditional systems such as stack databases or even Git. So we are looking at our data management processes and maintaining that trust in it throughout the life cycle of projects and back into operation and maintenance. Next slide, thank you. So finally, Now that we've defined this strategy and vision, we want to work collaboratively with the industry to make sure we take this in the right direction. So we're moving these technologies from rail industry readiness level 3, which is proof of concept, hopefully into 4, 5 and 6 to move it into trial. So that's it from me. That was a very, very quick overview. There's lots more to show and go into depth on, which hopefully I'll be speaking to a lot of you soon. So thank you from me, and over to Cole.
Thank you, Matt. I'm sure everyone will agree that what we've seen there is some really interesting, exciting proof of concept. If I can just reflect on what Matt told us. So we looked at the fact that these projects are there for the survey and design elements of what we do in the railway, and it's important not just to have the model that's being developed, but how we live, operate and maintain those models. And the proof of concepts that you've seen there aren't started from scratch. They build upon work that has been done in previous projects and programs in our previous control period, which was from 2014 to 2019, I believe, thinking at mind. The approach has been taken to look at an integrated tool set and think about it from a perspective of having the modularity in mind, and very much move from what is possible to what is doable. Matt outlined the vision around looking at the time spent, the reduction of errors, the data exchange, and the consistency in approach of the and whilst he outlined all of the opportunities and benefits, safety is still paramount to everything that we do. And he then showed us the life cycle of the projects and where these proof of concepts sit in that life cycle and where they're anticipated to provide the most benefits. And then he went on to show us some of those proof of concepts. So we saw the tail lamp camera, which is already being utilised by 20 projects and to date has captured 5,000 miles of the UK network. So these proof of concepts aren't imaginary. These are actually providing real benefits to the railway today. We looked at machine learning and the railway asset identification system to align the data stores to the downstream processes. And then we looked at Atlas and how we can use that system to train, and we can train it ourselves. And again, other programs are using these proof of concepts to support their outcomes. We then looked at BIM visualization and how we visualize the physical system of the and then finally, Matt took us through the importance of data management and how, although he couldn't show us today, there are other concepts that have involved things like distributed ledger and stacked databases to improve the data management that underpins all of these tools and models that have been developed. And the next steps for this project is to take these concepts further and move these to formal trials. So some really exciting work in this space. I'm sure you'll agree, some of the things that we've seen there are really, really important and really will push the programme on. So it's great stuff. And I'm sure lots of people will probably have liked to hear the 3-hour presentation that Matt could give, but unfortunately, we do have to move on. And so with that in mind, I will introduce our next speakers, which is Clive Roberts from the University of Birmingham and John Walker, who are going to talk to us about simulation environments for future CCS and generic validation. So welcome both of you, and over to you.
Thank you very much, Carl. Thank you. To introduce myself, I'm Clive Roberts. I'm Professor of Railway Systems at the University of Birmingham and Director of UCRIN, the UK Rail Research and Innovation Network, and I will be speaking today with John Walker.
Good morning, everyone. I'm John Walker, Principal Innovation Engineer working for Network Rail. I'm here today to talk about a synthetic environment project where the rail industry has the opportunity for a transformational change. The synthetic environment will link a combination of models, simulation, people and real equipment in order to form a common representation of the world. This will bring consistency and concurrency across previously discrete activities. Nicola's introduction to today's session discussed the challenges faced by the rail industry, and the development and delivery of the synthetic environment will address a number of these challenges. Our current verification and validation systems are applied to bespoke signaling designs, which limits the opportunity for efficiencies. The process requires the operational railway to be shut during the commissioning phase. This causes significant disruption to passengers and freight users. and significant cost inefficiencies can be traced to the manual, competency-dependent design, verification and validation processes, including on-site testing. To address these challenges, we will deliver an openly accessible synthetic environment for industry-wide use. The synthetic environment will help to achieve Target 190+ targets by supporting efficient, traceable digital design, verification and validation, moving towards testing and zero on-site testing state, greatly reducing disruption to passengers and freight. Reduced on-site testing is vitally important, but we're not just focusing on that. The synthetic environment will be used across the life cycle of scheme design and operation, enabling efficiencies in driver and maintainer training. The first part of being able to achieve our vision is the initial research phase of the project, which delivered a horizon scan and feasibility assessment. As you can see here, we've worked on with a number of partners. The Target 190+ is a collaborative programme. It's important to have sector engagement and industry buy-in to the findings. We wanted to develop a consistent consensus view on the current and potential future state of synthetic environment for the rail industry. Working with UKRIN has enabled skills, experience and knowledge to be brought together in a way that might not have been achieved for many months using normal procurement routes. UKRIN were able to partner with Atkins, Siemens and Thales to provide a balanced view from industry experts. Using this collaborative partnership, we were able to undertake horizon scanning, looking at the art of the possible within the rail industry and adjacent industries. The information from the horizon scan was used to inform the feasibility report, determining the art of the doable within the rail industry. As you would have heard from in early presentations, the whole system approach is one of the key drivers for Target 190+. This is not just a technology project. It's about bringing together the people, process and information to provide a solution to solve a problem. We recognise skills changes will be required. We need to identify the required skills changes and transition from the existing to the future state. People need to be equipped with the skills to use the synthetic environment confidently and effectively in order to reap the greatest benefit from the technology. Information will be delivered through the Asset Information Efficient Collection and CCS BIM projects introduced earlier by Matt, raising the confidence and credibility in the synthetic environment data sources. Understanding all of these and by integrating them around the technology, it allows the changes to be a success and feeds into our thinking throughout all stages of the project. I now hand over to Clive, who's going to talk about the horizon scan and feasibility reports.
Thank you, John. So I'm going to talk to you about the short project that we undertook to look at the horizon scanning, feasibility and road mapping in this area, and how we brought together the capabilities from within UKRIN, from the University of Birmingham, the academic background, with the practical expertise from Thales, Atkins and Siemens, both from the rail industry and other adjacent industries. So we structured the work into these three phases, really to start looking at what was going on in the rail industry, the current state of the art, but also what was happening in other industries. Then to start to think about how this could be applied to the rail industry to meet the objectives of the T190 initiative, and then setting out a roadmap with some milestones and clear outputs so that we could assess and articulate how this could be achieved in a timely manner. If we then move on and start to talk specifically about the horizon scanning phase, the key part here was to initially look at current practice in the rail industry. And many of the things that I now will talk about, I'm sure many of you will be aware of and will have personal experience of. But we are used to using simulation tools in the rail industry, but they're quite disparate, they're not interconnected, they are very specialised in the specific areas that they are focusing on. The industry itself, and particularly those that are in charge of rollout programs, are quite averse to risk and change, and generally our way of introducing new initiatives such as this may be to piggyback them onto existing projects, and that causes some issues. And then in terms of how we use data currently in the industry, that's generally quite manually driven. We generally actually end up collecting the same data multiple times, translating it into different formats, and we don't have this single source of truth that we've already spoken about today around how we think and use data. And there are significant disconnects in the V life cycle, in the development life cycle of projects, between that first phase where we specify projects, and mainly at the Network Rail stage, as that moves through to suppliers, and then as systems are integrated together again, we don't have a sort of golden thread that hangs all of that process together, which could have benefits. Now, we know that there's other work that's going on at the moment around the industry. So, for example, in the rail industry, we're using doors to gather requirements within Shift to Rail. There's various initiatives. At Birmingham, we're involved in, for example, projects like Moving to Rail and Performing Rail, but there's also initiatives around projects like X to Rail that are looking at next generation testing. There's also capabilities, both within the test, validation, verification, integration work that Network Rail are doing, but also some of the capabilities we have amongst our universities and UCRIN partners. But they're rail individual initiatives. What we wanted to then do is look at what was happening in our adjacent industries. And we identified a number of industries where we thought there was commonality with rail, i.e. where there was a safety critical nature, a very distributed nature, a control nature to how simulation and synthetic environments might be used. And what we found is that in those industries, simulation was much more common, and there was a more strategic approach to how simulation was used. The actual value of simulations and how the outputs of simulations and work within synthetic environments were built into the design process much more quickly. And we observed that real world testing had been reduced in parts, but more importantly, the synthetic environment, the virtual world testing, was really helping to improve dependability and de-risk the rollout and integration of new technologies and processes. So on the slide now, there's three specific examples. Covert, which is around collision avoidance and the simulation work that's been going on there, and the standardization that's been going on in that space for some time now. Work within the military and aerospace area that again is well developed, and Thalys's work, particularly in driving simulation and driving training. All of these areas are where these synthetic environments form part of the development life cycle of programs and projects, and are really supporting the initiatives along the lines of what we want to get out of T190. Now, if we then start to begin to talk about the feasibility phase of the project, what we found that the key parts to what we need to do here is integrate existing initiatives and capabilities and produce standardization to allow that to happen. So as I've said, there's lots of things already happening in the rail industry, but they're not integrated, and we have no real means of joining them up into one end-to-end system that's able to support projects and programs through the entire life cycle, from conception to operation. So what we are looking here in terms of the feasibility of doing is linking tools, producing the data standards that allow COTS, commercial off-the-shelf systems, to be integrated to serve the purposes that we are set out to achieve. If we then start to talk about those enabling technologies and how we'll do this on the next slide, what you'll see is that we're proposing an approach that is based on case studies. So if we move on to the next slide, we'll start to talk about case studies, how those case studies are developed, the criteria for acceptance, and how we consider that, and how we particularly pick up particular use cases to then finalize industry requirements and build those into a specification. So we've set those feasibility targets and feasibility stages out into a roadmap, which John is now going to talk about.
Thank you, Clive. We were going to get one of those transitions wrong, weren't we? So what does the development roadmap for synthetic environment look like? The roadmap for the development of the synthetic environment is based on an agile delivery with iterations delivering working solutions. It will link to and build upon the capabilities being delivered by the ETCS testing laboratory project. To achieve maximum benefit from the synthetic environment across the whole life cycle, it will be capable of integrating into design and data tools such as those for scheme design, CCS BIM, requirements and test case management. The initial phase of delivery is the test-driven synthetic environment development, followed by the development of the formal test cases and then on into continuous improvement. During the formal test case development phase, we will look to establish industry use of the synthetic environment platform and integration with the ETCS testing laboratory. As I mentioned earlier, this is not just a technology project. During the first two phases, when the people and process elements will be developed and will be piloted with the first applications of the synthetic environment. So it's good to develop a system, but we need to demonstrate it's successful. We'll do this by using the synthetic environment to take the ETCS test yard through scheme development and implementation of suppliers' solutions to demonstrate their match fit, proving their systems work, integrate and are fit for purpose. This brings the benefit of separating system development and testing from the application project. As the synthetic environment develops, we will be working with the East Coast program to identify opportunities for early implementation where benefits are identified. We expect that the synthetic environment will be used in parallel with the traditional design process for a phase of the East Coast program to demonstrate the benefits and to test the system against the real-world application. You'll hear more about the East Coast program and how we are collaborating with them and the Target 190 Plus program tomorrow with Mark Ferrer. The aim is to be able to use the synthetic environment for selected elements of the first 3 signalling renewal schemes in the long-term deployment plan by 2025. These cover vital sections of the West Coast Main Line, Midland Main Line and East Anglia route, including Peterborough to Kings Lynn, on the Anglia route, and the Warrington and Wigan area in the West Coast Main Line North. Opportunities for early wins are being explored, particularly in the area of validation, where we can utilise the work undertaken by the Asset Information Efficient Collection project. One such example is validation of Belize positioning. I now hand back to Clive to explain how the synthetic environment relates to the system engineering V lifecycle.
Thanks, John. So to bring this vision together, to bring this plan together, I thought it was a good idea to try and articulate this across the top of the V lifecycle that I'm sure many of you are aware of, where on the left-hand side, we talk about concept definition, how we consider what a scheme and program should deliver, and then start to define it in detail. And so that's all about decomposing a high-level mission analysis down to specific parts. And on the right-hand side, how we begin to integrate that all back together again through single subsystems tests and overall system integration. And then the V lifecycle on the slide here is then extended to talk about deployment, use and operation. So what we're talking about here is a synthetic environment that can support all of those stages. In that early stage of concept definition, start to make sure that the business case works, the overall scheme capabilities are articulated in the right way. But then as we move into system definition and through procurement cycles, that synthetic environment and the models underneath it can be passed to suppliers so that they can build on this and add what they are actually supplying into that model. That model and the synthetic environment can then be used to test, both to support physical testing in the real world, but also virtual testing and hardware in the loop type testing, and then also supporting those integration activities and final validation, again, both in the physical domain on the side of a railway, but also in a lab-based environment as well. This gives us much more scope to be able to verify and validate systems, not only from a safety case point of view, which is where we are at the moment, but from a business dependability and overall business risk point of view. And then into the deployment and operations part of the life cycle, we can keep the synthetic environment up to date, and it can be used to look at both maintenance and operations, but also how upgrade programs can work all the way through to retirement. So we create a golden thread throughout the program that both saves us cost because we're not reinventing the wheel many times. We're not reworking the same thing over and over again. We're able to bring the best in class from existing work in the rail industry and in adjacent industries and streamline both in terms of speed, but also in terms of accuracy and consistency in our design lifecycle. So finally, I'm going to pass over to John to bring our presentation together.
Thank you, Clive. The synthetic environment can realise huge benefits to the rail industry, delivering a disruptive transformational change. As Clive has mentioned, feasibility reports have identified successful deployment of synthetic environments in adjacent industries, showing that it can be achieved and applied to the rail industry. We need to work collaboratively with industry to ensure this is a success, and key to that is input from stakeholders. So if you want to know more or to get involved, please feel free to contact me. The project is now moving forward with pace and is considering the procurement options and routes for the future phases. An early notice of procurement has now been issued, seeking to engage with interested suppliers in relation to the proposed procurement and undertaking a virtual suppliers engagement event. Target 190 Plus procurement will be covered in more detail with Phil Bennett's webinar tomorrow. Thank you for listening, and I now hand over to Carl.
Thank you, Clive and John. And now I have the task of trying to summarise everything you've just told us in less than a minute or so before I can hand over. So let me try my best. So we first heard from John, who told us about the fact that current verification is applied to mainly bespoke designs, and actually during the commissioning phases we have to shut the railway. So there is this problem statement for a synthetic environment which could give us the efficiency, the approach to zero on-site testing, and we can use it across the entire life cycle. And so the project started with that horizon scan, which would inform the feasibility and then move into that roadmap. And the use of UCRIN gave us advantages in that collaborative partnership. But we mustn't lose fact that this all comes around to the system approach, like we heard yesterday from Imtihal, which covers the technology, the people, the process, etc. So it's not just about the technology, it covers all of those things that we went through yesterday. Clive then took us through each of the stages of the project, starting with the horizon scan, which looked at everything inside of the industry, but then also looked at adjacent industries. And what they found was that simulation was very common and built into the design phase a lot more quickly. And virtual testing was actually de-risking the rollout of these new technologies. I've then talked about the feasibility study, which looked at integration and standardization, before John then showed us the roadmap for synthetic environment development, which we're going to use the agile methodology. We're going to look at test cases, we're going to establish those test cases and then move into continuous improvement, and then work with partners like the East Coast Digital Programme to demonstrate that the synthetic environments are match fit for use in GB Rail. Clive then showed us the V life cycle and how the synthetic environment can support all of these stages across that life cycle, including testing and integration and validation, and the fact that the project is going to bring the best in class from rail, but also from other industries at approach. And then finally, John took us through the next steps and the fact that we're considering procurement routes for the future phases. And whilst there will be more spoken about tomorrow with Phil Bennett on procurement, there is a procurement opportunity coming out of the Target 190 Plus programme in this space now. And so with that, I hope I've summarised that well. But with that, we'll now hand on to James John from Ember9 to talk about national business continuity. So James, over to you.
So hi, I'm James Yolland. I'm working on the FCCS National Business Continuity project, and I'm a security and resilience expert looking at, strangely, security and resilience within Target 190. Now, I've been in the industry long enough to know that most people, or a lot of people, think of security and resilience as a bit of a black art that's focused primarily on meeting regulations. And while regulations are critically important, especially in light of the relatively recent UK Network and Information Systems legislation, they're far from the sole focus. You see, the step change in technology that Target 190 is going to enable means that an effective whole system approach to security and resilience is going to be, well, absolutely fundamental to ensuring benefits are realised in operation. So what is security and resilience? Why is it so important? Well, security is all about protecting a system from threats, and resilience is all about efficiently and effectively dealing with the incidents that result when those threats breach your security. So what are these threats? Why are they so critical? Well, threats are pretty much anything that can adversely impact the operation of a system and therefore prevent you from realizing the benefits of its operation. So what this means is that effective security and resilience requires the coordinated interaction of a very, very broad range of disciplines, everything from physical security and cyber security through crisis management, emergency response, business continuity and disaster recovery. And that's before you get into the related disciplines of safety and systems engineering. So it is complex, but get it right and the benefits are wide-ranging. You not only end up with a system that's got better protection and higher levels of availability, it's more safe and secure because you've got fewer incidents, but crucially you also end up with a more adaptable and tough system that's better able to deal with both those, well, day-to-day bread and butter continuity events and those big far-reaching one-off crises like COVID-19 that we're currently going through at the moment. So what does this mean specifically for Target 190? Well, if we get security and resilience right, and we aim to do so, then not only are you going to see those cost reductions, so lower life cycle costs, reductions in terms of the unit rate, but you're also going to be able to see performance enhancements. So you're going to have a system with higher levels of availability and capacity because of the reduced numbers of incidents, and you're going to see more safe and continuous operation of the railway because you're better able to deal with those incidents when they happen. But crucially, if you plan not just for security and resilience in operation, but also in transition, then you're going to be able to de-risk that transition and migration activity, and so you'll be able to easier and earlier get those benefits. And what this means to do this properly is that this project needs to engage with a very broad range of stakeholders and address their needs. Everything from suppliers and regulators, train operators, freight operators, routes and regions, all the way down to the individual projects within Target 190 Plus itself and influencing their designs. So it was identified very early on that this project needed to act as a hub of best practice for security and resilience within Target 190 Plus itself and ensure those golden threads for security and resilience are both designed into those individual solutions and remain concurrent, consistent and unbroken through design, through transition and into operation. So this next slide shows the ways of working of that best practice hub. You'll note we've not invented the wheel here. This is just purely the house and three pillar approach that's used by wider industry and government. The pillar to the left is all about our activities related to engaging with projects, influencing designs and ensuring security and resilience by design. But that's not enough because you might have individual designs that are secure, but the whole system as itself is not secure and resilient. So crucially, that coherence is provided by our central pillar, the blueprint, which is the development of a security and resilience viewpoint on the architecture. And finally, we have our governance and assurance pillar off to the right-hand side. For those in the security trade, that's our GRC pillar or our governance, risk and compliance pillar. And that focuses on ensuring compliance within the blueprint, that security and resilience view for the whole system, and with engagement and support. So that's our individual solutions and projects with individual solutions. That pillar is supported by an integrated working group. And we've engaged regulators, security, BCM and various different policymakers within Network Rail and the industry to achieve that. So what this means, these ways of working, is that this project needs to go through a number of different phases. Now, we've already completed phase 1 and phase 2. Phase 1 was all about setting the requirement for this particular ways of working and how we were going to achieve it. And phase 2 was all about establishing this particular hub, the security and resilience best practice within the programme. And we're now moving on to phase 3 and phase 4. We see phase 3 and 4 very much running concurrently and iteratively. Phase 3 is all about developing that security and resilience viewpoint on the architecture for whole system security and resilience and influencing designs within individual projects. And phase 4 is all about extracting elements from those designs and preparing them for transition ultimately to operations. So if we focus down now on what are the nearest crocodiles to the canoe for this particular project, as I've said, we've already completed phase 1 and phase 2, they're greyed out, and you'll see some of the key milestones that we've achieved to the left-hand side. For example, our strategy is now published, it's been out for wide review amongst industry and regulators. Now, to date, we've primarily focused on resilience, and that's because the sheer complexity of the resilience solution for Target 190 means that it's technically easier to eat this particular elephant from the tail first and start at the resilience end of the security and resilience lifecycle. So one of the first things we'll be doing in phase 3 is including and integrating those aspects of security that we've yet to encompass. Additionally, what we'll be doing is focusing down on quick wins. Now, to be fair, we've already been doing this, as it's never too early to focus on a quick win and try and exploit it, but this is really going to be a focus of the activity as we move into the next financial year. And that really is a quick cant around the houses for security and resilience. I realise I've only been able to scratch the surface, and there's a lot of technical detail behind this, but there's a Q&A at the end if you want to ask me some questions there, or you can reach out directly to me after this webinar. And with that, I'll hand back to Carl.
Brilliant. Thank you, James. So James there spoke about security and resilience and was explicit in saying that we don't just solely focus on trying to meet regulation, that for a whole system, it's effective as a whole system approach to security that's required for our programme. But more importantly, James showed us how if you get security and resilience right, it can help programmes like Target 190 achieve its outcomes, specifically in relation to not just the development, but the operation and transition, which ultimately means programmes like Target 190 Plus will be able to deliver benefits earlier. James outlined the fact that the breadth of stakeholder engagement for this project is really, really wide, and outlined the ways of working the project has been going through, which is based on the 3-pillar approach that he showed us. Now, this project has already completed, as James says, phases 1 and 2. And phases 3 and 4 are shortly coming down the pipe in a 4-phase approach. And this will cover aspects that have not yet been encompassed in the project and how we integrate those, but also looking to further exploit quick wins in the project in an effort to demonstrate that approach to security and resilience. And with that, that completes today's presentations on the webinar. So again, before I hand over to our community on our question and answer session, I'd just like to thank you all for attending the webinar. I hope you found it very interesting and the things that we've seen today. As I said at the beginning, we will be circulating after this the webinar recordings, the slides that you've been shown, and the Q&A document where we will answer all of the questions that have been submitted across all 3 days. Once again, if I can ask those of you that aren't staying for the Q&A to please complete our feedback survey. We do read them and we do take into consideration all of the feedback that is coming to us. We'd also like to thank you for the feedback received so far based on yesterday and our previous webinar. It's really, really great for us when we receive that feedback because it shows us what we're doing is what you're asking for. So we really, really do want that feedback from you. And the last thing as well is to say, as everyone has said today, please connect with us. So as I said, all the speakers' presentations we sent out, you'll have their names and where they work. So you can find them on LinkedIn, probably find some of them on Twitter, but also reach out to us directly if you want to find out more information. So I said, now we're going to go into the Q&A. So for those of you that want to leave us now, thank you very much for your attention. And so I will hand over to Okamute to run our second Q&A session.
Thanks, Carl. And thank you to all of our speakers and to our audience for joining us this morning. We have several questions that have been submitted throughout the presentations. And just as a quick reminder, if you do have a question that you've not yet submitted, please enter it into the Q&A chat box and we will get through as many as time allows this morning. So the first question is, so how will the synthetic environment impact current design and testing roles or jobs in the railway? Clive.
Yes, so in terms of the synthetic environment work, there's some real impact in terms of jobs and skills required. And it's the same as you would observe in other industries. So there's a need for more digital skills and understanding, but this doesn't take away existing testing roles and verification and validation roles that happen on the railway. What it does, it augments that work with other capabilities. So in addition to doing some of the physical tests that we might do on the railway today, we'd enhance some of that physical testing using the synthetic environment work, but also in parallel, there'd be work that would focus more lab-based and more test center-based on bringing systems together. So key issue about equipping people with the right skills, both to develop and use the synthetic environment, but then particularly in that testing space and using space, augmenting existing capability and job roles with new tools and sources.
Thanks, Clive. So our next question is, so if there are any trials in the future, would you consider Northwest and Central Works delivery signalling for the deliverer? Carl.
Thank you for that question. So I guess the short answer is we will, as a programme, will consider any avenues to trials. There's no specific reason why we picked certain areas unless it's offered us an opportunity to collaborate with another project that may bring us economies of scale or similar scope or scope overlap. But specifically related to that question, if the questioner has got a specific trial in mind or specific user case that they have in mind, then please reach out to us as a program team, and if the trial site and the conditions meet the project needs, and I see no reason why we wouldn't trial some of the concepts that we're doing in those places. I would temper that with that we can't obviously trial everything everywhere, so we do have to, as a program team and projects, look at where we get best bang for buck and the best outcome from the trial and the conditions for the trial. But yeah, absolutely consider all sites as part of doing what we're trying to do.
Thanks, Carl. So our next question is, so how are you addressing information security across the programme? How are you making sure this is covered in sufficient detail across each of the projects? And how will this be managed as the need for information sharing across the industry increases? James. James, you're still on mute.
Ah, yes, you see, I'm the first to do the speaking while on mute. I'm quite proud of that. But yeah, so I'm hoping that the presentation I gave today provided some insight on that in terms of the ways of working at how that will be achieved. In terms of the detail of how we do that, beyond what I presented today, I think probably if we come back on that, because there's a lot of detail behind that.
Thank you, James. So our next question is, how will the synthetic environment lower the human interface risk when installing, testing and modifying the system? John.
Thank you. So lowering the risk in installing and testing the system. Fundamentally, it's actually reducing people going out on site with boots and the ballast. Our aspiration is to reduce the on-site testing elements, which will therefore reduce the risk of staff working on site. By reducing the on-site testing, we're looking to move it towards the laboratory, reducing that risk and also increasing safety by having increased testing coverage. With installing Target 190 Plus programme, I'm not necessarily looking at how we go about doing this, but it would look to move towards radio-based ETCS signalling, and ETCS level 3, which by virtue will have a reduced requirement for installation of equipment with the reduced equipment and removal of axle counters, etc. It's not really a drive for Target 190 plus, but elements of it will lead to reduced risk and reduced installation requirements.
Thanks, John. So our next question is, has it been studied how the digital twin could help in predictive maintenance and material management to improve the efficiency of the supply chains? Matt.
Hello. Yeah, I was thinking I might get away with the questions then, as they were all going to other people. But no, it's a really good point. We are constantly studying the sort of digital twin, and as I said in the presentation, it does mean a lot of things to a lot of different people. So materials management and product and component parts are an absolute key element to it. We're obviously doing quite a lot of work with the Intelligent Infrastructure Programme and how we hand over to those guys. So the materials management is a really interesting bit, and I would welcome more feedback on that. The stuff I mentioned around the BIM principles, aligning our semi-structured data to elements such as COBE and IFC will obviously help with that. But I think I'd need to understand more of a deep dive into the question to give it probably a more full answer. But it is definitely an avenue we are exploring along with everything else. So I would welcome more feedback on that, really, if that's okay. And sorry I didn't properly answer the question, I guess.
Thanks, Matt. So our next question is, although the aims of the Target 190 Plus programme are around making asset renewals more cost effective, a lot of the enabling projects have a crossover with enhancing ETCS and getting closer to enabling ETCS level 3. Is there a specific link between Target 190 Plus and ETCS level 3 ambitions? Nicola.
Yes, absolutely, there is a link, and in fact within the T190 programme we specifically got a project focusing on making sure we're fully ready to implement and deploy ETCS level 3 on the network, because as Matt and John have just mentioned, if we can remove more assets from the trackside, we make it a safer environment for our trackside workers. And in fact, we've already done quite a lot of work on moving towards the implementation of level 3 through the work we did a few years ago on hybrid level 3, when we collaborated with ProRail and a number of the signalling suppliers to develop and do a demonstration of hybrid level 3 with 2 trains on our test track at the UTCS National Integration Centre. So I think we're well on the steps towards implementation of level 3, and we're actually now really looking for the first project to deploy it. I know some of our colleagues in other countries, Norway, France, the Netherlands, are also very much actively looking at deploying the first application of hybrid level 3, but I'd like the UK to be first in that, so I'm very interested to see which regions around the country would be interested in joining us to make us be the first to do that.
Thank you, Nicola. So our next question is, can the synthetic environment be used to reduce the testing and trialling of new technologies and their introduction onto the infrastructure? Clive.
Yes, I think is the straightforward answer, certainly. And where I showed that V diagram where we're coming back up the right hand side where we're doing that testing, that verification validation phase, that's very much supporting both conventional testing, the kind of things that we do on the side of the railway, but also new kinds of testing that reduce the risk of product and system integration, both from a technical point of view, but also from that people and process point of view. We can do that in the lab and have a whole new set of capabilities that we struggle to deliver at the moment. We've done some work at the university in this space already on CBTC systems, so on metro signalling systems, so with hardware in the loop. So we know those sorts of things can be done, albeit there is potential to do lots more than, if you like, the state of the art in terms of research. I think John probably can add a bit more around how other facilities that Network Rail have can be used in this space as well.
Yeah, so building upon what Clive said, it links back into my presentation where we talked about demonstration suppliers being match fit as one element of the development to the synthetic environment, and how we're linking with the ECCS testing laboratory. So Clive gave it its full term, which is the testing, verification, validation and integration facility being delivered, and how we'll take suppliers' systems, develop them against the test yard being developed by generic design and the full suite of requirements, such that we can prove that they're match fit and take them through an element of ORR authorization for ETCS and attain a level of safety certification from them, removing that significant risk from the application projects, which often causes difficulties and problems for the programme. So, like Clive said, the short answer is yes, absolutely.
Thanks, John. Thanks, Clive. So our next question is, so National Cybersecurity Centre, NCSC, have changed their view from secure by design to secure by default due to the high investment in time and effort to achieve security by design. How will Target 190 Plus, by its modular design, that we keep the security of the architecture and whole system consistent whilst maintaining compatibility with the rest of the ecosystem? James.
Thanks. Well, there's a very in-depth answer to that. I'm going to give you a quick over the top, because I think that's probably about 3 questions in one, and then we'll come back on it, I think. So in terms of security by default, stroke security by design, there are semantic differences, I get that, but primarily it's about security and resilience being designed into things from the ground up. So yeah, no, I'm aware of the change. In terms of how we're going to maintain consistency between what is the overarching architecture, the individual solutions within that, and the wider ecosystem, well, we're going to be introducing, and indeed we are, system engineering principles. It's the interaction between those if you like, those pillars, that central pillar, which is all about coherence with the architecture and the wider ecosystem, and then that left-hand pillar, our engagement with projects, which are about the individual solutions. We're going to use the interplay between those two, and we're going to introduce some system engineering principles, which are largely around security and resilience principles for design, if you like, and operation, the rules that sit between underneath those, and the criteria that sit underneath those rules. And then we're going to be looking for reusable patterns for security and resilience within that architecture. So all of that will be done in parallel to the security requirements, and that is really how we're going to achieve it. But there's a much more detailed technical answer.
Thanks, James. So our next question. So the surveys will only save money in design, which only accounts for 10% max of the SAU cost. To cut the installation costs in half, the big savings will be reduced in manufacturing and installation costs. Can we talk about how this work leads to the 190K target? Matt.
Absolutely. So the initial cost of the survey might be 10% of an SCU rate, but the way I see the combined power of Target 190 with all the different projects, imagine if every project chipped away 10% of that SCU rate, you'd find a pretty quick reduction pretty quickly. So the technology and the processes and the data journey will save money and introduce efficiencies in those downstream processes, because as we said, once we develop that single source of the truth and we have the trust in the data, which is maintained throughout the life cycle of a project and back into maintenance and operation, we're not redoing work. We're not having to go back out to site and check stuff. We're also doing stuff around such as Belize and axial counter positioning data. So the same principles we apply to signal sighting, where we found some efficiencies, we managed to do it 13 times quicker. So those sort of that data in the right format at the right part of a project will also drive down those costs. There's also a big element of the handback of data. We don't hand back data as smartly as we should do, and we spend a lot of time and effort doing it, and it's not always accurate. So if we did an as-built survey at the end of every project, the efficiencies we would make there, we would know where our assets and our stuff is better to begin with, but as we then hand back the data, it would just flag up the deltas. So rather than doing 100%, we just have to look at the anomalies. So actually, that you are right, the snapshot is the start of the process, but there are efficiencies to be made throughout the whole stage, and every little bit of it we can chip away at. So what we're doing, Intertal talked a lot about Abacus yesterday. What we've done, we've mapped the data and these technologies to each stage, and we're basically trying to work out how each stage can be affected in the terms of efficiencies. So hopefully soon we'll be able to share some of that with you in more depth, and you can actually see how that is affecting that SCU rate and driving it down throughout the life cycle. So I hope that answers the question.
Thanks, Matt. So our next question. So cost and schedule reduction is a noble aspiration for all of us, but have we considered the increased risks and how best to mitigate them? Nicola.
Yes, absolutely. We've considered increased risks because as we introduce new solutions and new systems and new processes, we bring with them new risks. And so we've got to be very careful that by changing things and eliminating some of our existing risks, we don't actually go to tip the balance to the other way and end up with even more risks of what we're doing. So we're thinking this. I think we're approaching this very carefully across the programme in a balanced way, looking across technologies, processes and the solutions we're developing, and actively reviewing those in terms of the benefits and risks the solutions bring. So we really do have a rounded solution that takes all these things into account that we know is suitable for introducing for use on the real operational railway.
Thank you, Nicola. So our next question, so how is all of the analysed and post-processed data gathered by surveying used to improve the localisation of trains in real time? Another one for you, Matt.
Yeah, thank you. So localization is a project with inside of Target 190, and I know there are other initiatives across Europe looking at this. So we are constantly talking with those teams and aligning to it. One of the prime examples would be one of the bases of the RCA structure is the Topo 4 layer, the Topo 4 model in that. This survey data would obviously be used to sort of feed and validate that Topo 4. It has things like gradient profiles and stuff in there. So that would be a prime example how the data captured at the start of this process can be used to feed localization systems. So unfortunately, I'm not the expert when it comes to localization, but a lot of the technologies and systems are pretty similar. So we are working with those teams. And as I said, the prime example would be feeding things like Topo 4. But I would welcome more insight on that. Absolutely. So it's a good question. So thank you for that.
Thank you, Matt. Our next question is, how closely is Network Rail and the Target 190 Plus team working with the National Security Centre and Department for Transport to ensure that the requirements of the NIS directive and cybersecurity risk are managed, given this will be classed as part of the critical national infrastructure? James.
Hi, yes. So very closely, and there are sort of two levels we work with them at. So we engage DFT and NCSC, both of which attend our working group, the integrated working group on the governance pillar, directly. The strategy and various bits and pieces have been in front of them already. Then there's a second layer, if you like, of integration, which is internally through the Network Rail policy team. So we've engaged and integrated the security team and the BCM team within Network Rail. So I guess the answer is we're very aware that this will be part of the critical national infrastructure. So we've engaged very early, not just with people like, you know, Rail Delivery Group and all the rest of the stakeholders out there, but directly with the regulators.
Thank you, James. Our next question is, what is the impact on the need for zero on-site testing given COVID-19 and the reduction in passengers? John.
I suppose it will be a question answer session in the last year or so without asking about COVID-19. The conventional testing has a range of safety considerations, and we can continue on with those. There has been some initiatives, use of Talistai, etc., and bits and pieces by not having some of the testing, supervision of testing based on site. They're can be based remotely, so that's been worked through with the works testing community. But we're also looking at system performance and capability in the testing phase as well with Target 190, looking to broaden our range of testing to look at the dependability of the assets. And in terms of reduction in passenger numbers and number of trains running, still actually is a large proportion of trains running. A lot of freight is now being transported. Freight use is remained at similar levels to what it was before COVID. Whilst there's not many passengers on the trains, there's still quite a number of trains moving around as well, and we still don't want to disrupt those. So we're looking to still move to more appropriate working hours and working in better conditions as well on site. We're looking to enable more thorough testing with Target 190 without being reliant on drivers being present for the testing. Removing a lot of uncertainty as well from our testing. So I don't think what we're doing will be affected by COVID-19. In certain areas, it's allowing us to accelerate initiatives like the Talis Eye and reduction of on-site testing as we work towards testing in a better manner today. So minimal impact from COVID-19.
Thank you, John. So our next question is, what is the expectation of clients and stakeholders looking to purchase these new projects? Many are interested in how they can harness ETCS to provide more efficient use of existing layouts and infrastructure to run longer trains, etc. Are there any innovation developments focused in this area to more easily interact with other railway engineering discipline design processes? Nicola.
Thanks for that question. A very good one. And yes, we actually do have a project that is looking at those sorts of processes within T190. As I said in my introduction today, we could only pick out a small number of the projects to present on this, but we have a project specifically looking at generic design processes and another project looking at how to get the most out of ETCS technologies and the different areas of radio-based ETCS. And actually, when you start to deploy ETCS, just by implementing level 2 or hybrid level 3, for example, you can just increase capacity without actually having to make many other changes to the existing infrastructure. So lots of opportunities in that area, but I think that the area where the generic design project will particularly help is looking at those design processes. How do you select the solutions? How do you put them together? How do you take them through the design life cycle and take opportunities as afforded by the synthetic environment, for example, to do some upfront modelling as to what you can get out of the railway when you're in your option selection phase and you're trying to decide what the right solutions are to actually deliver the specific timetable that you want to achieve in maybe 10 years' time. And we can, through the use of these synthetic tools and this environment, actually sit in front of a screen and using the data that Matt's talked about, actually have a look and get a real feel for what the railway will be able to deliver in the future. So we really are moving away from having to imagine what railway performance would be like and what we can get out of the systems by looking at paper and imagining it. The move to all these data processes and the synthetic tools will actually allow us to really understand the benefits and the solutions that all the 29 projects in the T190 programme can bring, how they interact, and actually which are the best bits that deliver the right solutions for your bit of railway.
Thank you, Nicola. So we have time for one more question today, but as Carl mentioned, we will be circulating that Q&A document to answer all of the questions asked during the webinar. So the final question is, how does your data get into Ellipse? How do you reconcile different data records in different systems? Matt.
Yeah, hi, I'm pleased you've asked me that. So this is a prime example where I talked about the art of the possible, but actually we want to talk about the art of the doable, which I should just reference. One of my team came up with that statement. It was a fellow Wayne Cherry, so he'll badger me if I don't mention that. But one of the prime examples is things like our SIFT tool, so Signal Sighting Forms tool. We've built an API, so as the system goes down and automatically detects the signals, it can link into that system to basically validate, to say, yes, I agree with what you've detected. Or if there's a delta, the human being can then look into why the data records don't align. So we are trying to have access into those systems such as SIFT. Ellipse is a good case study, and it is the one we're moving on to next. So when I talked about the RAIS system, so the machine learning developed with Fujitsu, Western Wales are actually linking back into Ellipse now. So on their region, that's exactly the use case they're looking for. So that's being explored through that avenue. So detecting the assets, validating it and handing it back. Obviously, we need to look at the data coming back when we've commissioned a project, which is the next key thing, which is why we talk about the data and BIM, not just being a nice shiny model, but being the data set that we use to operate and maintain the railway going forwards. So the hand back into those systems is absolutely key and is being explored. So thank you.
Thank you, Matt. And thank you to all of our speakers and those who have submitted questions. I'll now hand back over to Carl for final wrap up before we close the session.
Thank you, Okamute, and again, thank you everyone for those questions. It's really pleasing to see the presentations have generated so much interest, and I won't lie, some of those questions were really tough, so I'm really proud of the guys for giving some great answers there, but proud of the audience for asking such tough questions. As I said at the very beginning, we will commit to taking any questions that we haven't had a chance to answer today, along with those from yesterday and the ones we expect from tomorrow, and publish those in a Q&A document alongside all of the materials from these webinars. So all that remains for me to say is to say thank you to our speakers today for their presentations, and thank you to you for your attendance, and please, as a reminder, if you could give us that feedback that will feed into future events, it would be much appreciated. But with that, I shall close today's webinar and say I hope you have a delightful rest of the day. Thank you very much.